The average med spa loses around $1,200 every month on missed calls alone. And research also shows that 80% of callers that reach voicemail won't leave a message, meaning all of those potential customers are instead reaching out to competitors. In today's video, we're going to build an AI receptionist specifically designed for med spas that can handle booking, canceling, rescheduling appointments, as well as answering all of your common questions, available 24/7, helping to reduce, those missed calls your med spa is getting and recovering some of that lost revenue. Okay, so let me show you a demo of what we are going to build.
Hi there, thank you for calling Therapy Clinic. How can I help you today?
Hi there, I just wanted to know the price of microneedling.
Microneedling for the full face starts at around £93 for new clients and usually requires 4 to 5 sessions. Would you like to book a free consultation to discuss further?
Yeah, but do you guys do like virtual ones, like over Zoom?
Yes, we offer virtual consultations via Zoom. I have availability next Wednesday, the 23rd at 10 a.m. Would you like to book
Can we
that?
do something a bit earlier, maybe like this Thursday instead?
Yes, we have availability this Thursday, the 19th at 10 a.m. Would you like to book the virtual
Yeah, let's do
consultation
that.
for that? I'll need your phone number, name, and email to book the appointment.
Okay,
Could you
yeah, my name is Hugo. My phone number, you can just use the one I'm calling from. And my email is hugo@gmail.com.
Your virtual consultation is booked for this Thursday, the 19th at 10 a.m. We'll email the Zoom link to hugo@gmail.com.
Amazing, thank you.
And by the way, if this is your first time watching me and don't know who I am, my name is Hugo. I run Artillo AI. And if you want one of these voice AI systems built for your business with all the integrations, the logic, the prompting, all handled by us, you can contact us via the form on our website, linked down in the description below. Okay, so in this video, I'm actually going to show you a bit more than just the code because we are building this AI receptionist on Pipecat. So it does involve code. I'm actually going to show you also the principles and why I built the system the way that I do. And it's going to show you a bit more of an insight into how I go about building these types of systems and why the way that I go ahead and build it and the way that this receptionist has been built is better for production, for real world calls, for accuracy and reliability. So we can start off by looking at how the old system used to look like and how most people would build their AI receptionist today, and how I kind of tried to build them a few months ago and found myself struggling. So we have a normal pipeline, which is speech to text, large language model, and text to speech. Now, this old system really struggled with older large language models too, because these large language models weren't as good. Now this old system is actually a little bit better in the sense that the large language models are so much better that this old system kind of is able to do okay. But yet the new system, which I'm going to talk about in a second, is still a lot better. So the old system, we have our audio that comes in from the user or the customer, whatever we want to call them, and it gets transcribed by a speech to text model. Then that transcription, so the text that the user said, is sent to the large language model. And in the old system, this is where we would simply cram all the information, the instructions, the rules, and facts into the system prompt. And essentially with this old system, we would hope that the LLM follows the right information, follows the right part of the prompt at the right time. This was the old system. Like I said, nowadays the LLMs are much better. We have GPT-4o, we have GPT-4.1, we have GPT-5 if you even decide to use that. And all of these new open source models too. And they are much better at following instructions, but yet this old system is still flawed. After you get your response from the large language model, we would go to the text to speech as normal to send back the audio to the user. So that was the old system. Obviously in the large language model, you'd have your system prompt and tools here too. But that was the old system. And yeah, I just found it to be unreliable for myself. As even with better models coming out like 4.0, 4.1, where, they weren't amazing because the latency was quite high, I still found this to be an issue in moments where the instructions got really large, the information that the LLM had to hold got really large. It started to struggle, especially in later turns of the conversation. So when, me and the LLM or someone with the voice agent has been speaking to it for a while, at multi-turn conversations, it would struggle. So let's look at the new system, which the new system involves something called scenarios. Now, scenarios is a step between speech to text and large language models. So this is essentially a RAG database or a RAG step that happens in between the transcription, so after the transcription and before the large language model. So what happens here in this pipeline is the speech to text transcribes the audio as usual. Then it is actually sent as a query to the RAG database, which then retrieves the maybe most 5 relevant or maybe most 10 relevant scenarios, which are then inputted into the large language model's system prompt, which then generates this answer and is sent to the text-to-speech model for audio to be synthesized back to the user. So that is all that is different in the scenarios or the new system structure. Let me show you what scenarios actually look like so you can understand why they are so powerful and how they are so beneficial for reliability, accuracy, and kind of that production grade system like I was talking about. So a scenario is essentially just a JSON that has 4 separate keys, that being context, user says, assistant says, and response guidelines. 2 of them are for the LLM and 2 of them are for the actual RAG or for the embedding and for the accuracy of the retrieval of the scenarios. So in context, this is for the LLM. We're just giving context to the LLM about the scenario. So if the user is asking about the price of microneedling, which like you saw in the demo, I did ask, we then have the response guidelines, which are our microneedling treatments start from £93 per session, depending on the area. A full course typically ranges from 3 to 6 sessions, etc., etc., etc. So those 2 pieces of information would be passed to the LLM, and they are mostly for the LLM. Then we have the user says and the assistant says, which are both examples of what might the user say or what might the assistant say to trigger this RAG scenario. So when I say, as the user, what is the price of microneedling, that audio would be transcribed, and then that text would be used to query the scenario's RAG. So we want to put examples of triggers that could potentially bring back this scenario, which is why we have this user says and the assistant says. So that is how the scenarios look. The question is now, how and why would we use a scenario, or what would be put in a scenario, versus the system prompt? What kind of information do we put in each? So the core difference is based on one key question. What information does the LLM need to know at every single response it makes, regardless of the conversation's topic? So if we are talking about something specific like booking a consultation or the price of microneedling, that needs to be in the scenarios or the RAG. But in the large language model, we want things that are important at every turn of the conversation, no matter what the response is, no matter what part of the conversation we are in. As a med spa receptionist, we want that information that is useful to be in the system prompt. So here are some examples. For the system prompt, we might want context that is, again, evergreen and always useful. So for example, I find it useful to prompt my LLM to let it know that the user's inputs are coming from a transcription model and that everything it says is going to a text-to-speech model. So that just gives it some context about kind of the system that it lives in. And actually large language models are so clever today that that is quite useful for them, especially with transcription being a bit off. It might be like, oh, I can actually just assume that they're probably saying this. And so that is why that context is useful at every turn of the conversation. Another thing might be, the user. So let's say the user calls the receptionist. We actually take their phone number and we query our database with that phone number, and we retrieve some information about them, like their name, their email, maybe their past appointments, things like that, because they are a previous customer. That context is useful for every part of the conversation, no matter what conversation we're in or what part of the conversation we're in. That is going to be useful context. So that might be another thing we put in the system prompt. Definitely something we want to put into the system prompt is the response style. So how should the LLM respond? Should the responses be concise, natural, etc.? These things are always going to be the same. It doesn't matter what part of the conversation we're in. We want it to respond in the way that we kind of defined in the system prompt. Another thing would be overarching rules. So rules that are always applicable no matter the context. For example, always require a consultation before booking a procedure. Now, this is an overarching rule in the sense that it is basically always useful for the LLM to know this, because a lot of AI receptionist conversations with a med spa or in a med spa environment will be about booking some sort of a procedure, whether it be microneedling, laser hair removal, all these types of scenarios, and they always require a consultation beforehand. And so the LLM knowing that is pretty useful for it to know at every turn of the conversation, even if we're talking about something else completely random. Because if someone asks about what is the price of microneedling, it needs to know that, okay, if they want to book that procedure, they need to book a consultation first. So that's why I think that is a good example of an overarching rule. And essential facts, I think, are the last kind of key thing that should be in the system prompt as well. So opening hours, maybe the med spa's name, or maybe the med spa owner's name, in case that is, useful information, if people are talking about it and things like that. So those are the kind of things that we want to put into the system prompt. Now, the scenarios examples would be specific facts. So, what is the price of microneedling is a detail that is only needed when asked about. So that could be something we put in the scenarios, like you can see in this example here. Some other things would be dynamic informations, things that might change frequently. So med spas often have offers and promotions, and these things are dynamically changing, and we don't want to be dynamically changing the system prompt. Instead, we would want to be dynamically changing our database with those offers. So that would be an example. So situational rules, so rules that only apply in specific contexts, would be also another scenarios example. So this is kind of rules that are both about the use case. So in our example, about the med spa. So rules to do with the med spa, like, for example, one of them was always require consultation before booking a procedure, but obviously a situational rule, not an overarching rule. So for example, this could be, we don't do consultations on Tuesdays. This isn't that important, because if we're talking about the price of microneedling, before they are booking a consultation, they don't need to know that they can't do on Tuesdays. Only once we start to speak about consultations, that's when it would be useful to know that we don't book them on Tuesdays. And we also have the rules that the agent has to follow. So an AI might need to know that when a user tries to book a consultation, always confirm the user's email by spelling it out letter by letter. So the AI only needs to know this when the user has given them their email for maybe booking a consultation, like I mentioned, or maybe booking a procedure, maybe canceling something, etc., or searching up their record in the database, these types of things. So that is a rule that is only useful when the user has given them their email, because that's when they should be now reciting that email and confirming it letter by letter. So those are some examples of scenarios versus system prompt. So that is the new system structure. Now I'm going to show you how we're kind of incorporating this system structure for this med spa receptionist, as well as all the model decisions I made. So what speech to text model we're using, what scenarios RAG we're using, etc. And that's what I'm going to show you in this system right here. So here is our med spa system structure. I'm going to first talk about all the models I decided to use, and then I'm going to talk about these little bits of notes down here. So for the speech to text, for this system, I want to be using DeepGram Nova 3 because it is really fast and relatively cheap and quite accurate too. So that is just really the best AI voice agent, AI receptionist transcription model at the moment. Now for our scenarios RAG, because this directly adds latency to our pipeline and we want our receptionist to respond as quick as we can, we are going to be using a model called MinishLab Potion Retrieval 32M. Now this model has sub 1 millisecond embedding time because it is a static embedding model. And it can run on CPU, meaning you can run this whole scenario, this whole system on a CPU, which is so much cheaper than having to, rent a GPU. And for a med spa, it is economically not viable really to be renting a GPU to be able to do embeddings. So that's why we are using this type of model, which is really, really, really beneficial and so fast and still, 97% state of the art, which means it's 97% as accurate as the best models available today. So next, for the large language model, we're going to be using Cerebrus, Qwen 3, 235B, A22B, Instruct 2507. Every time I see this name, it makes me laugh because it is just such a terrible, terrible name. But this model is very fast. It is actually very intelligent. It follows my instructions well. It's not as good as 4.1 maybe, but because of how fast it is And because we're using this kind of med spa system structure, this new system structure, it is with the scenarios RAG, it is more than capable enough for this type of scenario. Then for the text to speech, we're going to be using Cartesio Sonic 2, very fast, relatively cheap. It's not the cheapest, but not the most expensive. And it's just natural and in general, very accurate and reliable. And then finally, for the turn-taking model. So the turn-taking model, I didn't mention it, but the turn-taking model basically decides, based on what the user has just said, have they finished their sentence? Are they done with what they are talking about? Let's say I asked something like, or let's say I say something like, what is the price of, and then I just stop there. The turn-taking model will basically decide they are probably not finished with what they're trying to say. So let's wait. And that is the entire job of the turn-taking model. Basically figure out, are they finished with what they're saying? If so, let's move it along the pipeline. If not, let's wait until they are finished. So we're using the Pipecat Smart Turn V3, which has recently been released, which is amazing. Again, CPU inference, meaning you can run it on your CPU, making it so much easier, so much lower latency, and it's such a small model as well. So well done to the Pipecat team, because that has been a game changer for this system. So let me quickly mention the scenarios RAG. I mentioned what embedding model we're using, and for the vector store, we're going to be using Qdrun. Qdrun is a vector database basically, and it is on the cloud. And you get a free cluster, which means you can, run this for free, and it is just very good, very fast. Obviously, it depends on your location. If you're hosting your cluster in London and you're querying it from America, that is going to take some time because you've actually got real world like distance latency. But if you're right next to it, the latency is around 10 to 15 milliseconds for a query. And I mentioned in the examples for these scenarios that obviously we want to put dynamic information in the system, in the scenarios. So that example would be the offers and the promotions. And with this Mespar system, we want to build a automation that automatically deletes, updates, and creates scenarios based on the, again, deletion, updating, and the creation of offers and promotions at the Mespar. So that system needs to be built too. For the large language model, the tools that we're going to build for this Mespar AI receptionist are going to be check availability, look up appointments for patient, book appointment, cancel appointment, reschedule appointment, take message, which take message is essentially, when we are out of office hours. So let's say someone calls the receptionist at 9 p.m. and there's an error. We can't transfer to a human. So instead we take a message and maybe send it to Teams, or maybe we send it to Slack, or whatever our system is for chat. We send it there to kind of let the reception or the actual Mespar know that there was an issue with a call at a time not in office hours. And so that's why we have the take message. Escalate to human can be also kind of seen as transfer to human. Essentially, it is just transferring to a human when there's an issue, but we are within office hours. We have look up patient and create patient, which is basically just getting the patient information, like the patient ID, and creating a patient if they are a new person who has never worked with the Mespar before. So for these tools, obviously, in this example, I'm not your Mespar, so I don't know what system you're using. You might be using MBO, which is MindBody Online. You might be using Zenoti. Any of the software that you're using, as long as it has an API, you can you can integrate it with these tools and get an AI receptionist up and running. Okay, so that is it for the overall look at the Mespar system structure and kind of an example of, a difference in the old system versus the new system. Now let's go into the code and take a look at what I've built in order for you to actually get this up and running yourself. So there is two main files that we need to look at, which is bot.py and server.py. So this AI receptionist will be on Twilio and Daily's SIP. So Daily is basically the company behind Pipecat, and they have a real-time voice, video, and AI at global scale. They basically provide global WebRTC infrastructure, and we're going to be using that because it is very fast. And as you can see, the companies that are using this, we have Scale, AWS, Nvidia, Epic, Cresta. We just had Vapi, if you saw that. We have Tavis, Google, Merkle, which is the fastest growing company in the world right now, Accenture. Basically, It is the best for global WebRTC, and it is the most production-ready transport system, and we should definitely be using Daily's SIP. So in server.py, I'm not going to go over this. Essentially, what server.py does is when it receives a call to your Twilio number, it transfers it to Daily's SIP and basically triggers your bot to start and like actually run. So that is essentially all that server.py does. Obviously, there's more to do with the server.py, but that is 99% of what it is doing. And it is a bit complicated to go into. If you want to actually take a look at it yourself, obviously go through the code, read it, or ask, your AI agent or ask your LLM what is happening in server.py, and I'm sure it can help you. For me, it is not that useful, and for most people watching this video, you won't have to touch bot.py at all, so there's no point you won't have to touch server.py, so there's not as much point talking about it. Okay, so let's go to bot.py. This is essentially the actual bot implementation. So the bot is actually this thing right here. Sorry, I'm trying to show my screen, but it's in front of me. So speech to text scenarios, RAG, large language model, and text to speech is what we're kind of defining in bot.py. So as you can see, we have OpenAI LLM service, DeepGram speech to text service. We have the local smart turn analyzer v3, Cartesia text to speech service, things like that. That is what we want in bot.py. So here we're doing some imports from a model config. So I'll show you this file in a second. Essentially in model config.py, we're defining the system prompt, the tools, and what the tools are doing. And yeah, we're importing all of those things. We're setting up logging. We're initializing the Twilio client. And here is what we're doing in the run bot. So in run bot, we're again enabling RAG, or basically initializing RAG, defining the speech to text model. So that is DeepGram, the LLM, which is Qwen3, as you can see with Cerebrus, and then the text to speech, which is Cartesia, like I mentioned earlier. So once those things are initialized, then what we want to do is actually format the system prompt. So here we have current date and time, which is equal to, the current date and time. We also have if patient, which is basically if that number that is calling our server is recognized, then we input the patient is recognized in our system, and we input some name, email, phone, and patient ID information. If they aren't recognized, we say no patient record found, collect phone number, name, and email before proceeding. So that is kind of what we're doing before we kind of initialize the whole bot. And then we kind of format this thing right here, which is basically formatting the system prompt with these variables. And the system prompt, again, is taken from model_config.py. And as you can see, we have these basically variables inputted here, and those are where the instructions are being inputted into the system prompt. So then we actually, define that system prompt so that Pipecat has access to it. And then what we do is we register all the function calls. So as you can see here, we have async define handle check availability. And then we basically put in, the parameters, etc. And then we actually query our tool. So that is our function. So we have that for all the different functions that I mentioned. Then we register all those functions with llm.register_function. This is just something that you have to do with Pipecat. Then after that, we set up all the conversational context. We have this little extract plain text from message content. You can kind of ignore that. It is useful for the RAG right here, as you can see. Then we have our RAG processor. So this is this thing right here, scenarios RAG. What it does is it basically takes the last assistant message and the last user message, turns that into a query, which is just literally this right here, assistant, last assistant, user, last user. Then that query is sent to RAG_lookup right here, which basically retrieves the top results from the RAG collection for the given query. And then we basically get the results back and push that into the system prompt. And then that is it. That is all the RAG processor does. So we can actually look at this in the pipeline with this right here, which is speech to text user CTX, which is just kind of all the user and the assistant messages. Well, actually all the user messages specifically, all the assistant messages are in here. And then we have the RAG processor, which is performing the RAG on the user stop. So when the user stops speaking, then we have the LLM, then we have the text to speech. So that is the pipeline. And then we just create the pipeline task. we have a turn observer, and then we have some event handlers here, which we can kind of ignore. They don't do anything really apart from handling recording of these conversations. So I'm going to ignore those. And yeah, and then we just have the transport and the bot, and that is about it. So none of this actually needs to be worried about, except for this kind of stuff at the top, which is defining what speech to text model we want to use, what LLM we want to use, what text to speech model we want to use, and how does our system prompt look like, as well as obviously registering all the functions. So that is about it for all we need to know for bot.py. So you don't have to change a lot in bot.py either. Now, model config.py is where you put your system prompt. Now, I am going to state that this system prompt is not production ready. This is a demo system prompt. It is not production ready. Obviously, everyone's MedSpar is going to be different. The system prompt that you need is going to be different. System prompt and prompting in general is very, very important. And please do a lot of due diligence to make sure your prompt is working well in production. This is a very difficult thing to do. Maybe in the future, I'm going to make a video about it. It's such a difficult thing that it's hard to really even make a structured video on how to best prompt. It is kind of more of a test and give it a go type of thing rather than, use this exact system structure. But yeah, this is not production ready. So you're going to have to do some work on your own on the system prompt. So then what we have later is this tools, basically the list of tools. So we have check availability, look up appointments for patient, book appointment, etc. And that is just the list of tools that we're passing in bot.py. So if we look at it here, we have tools as function tools, and we're actually using that and defining that in the context that is being sent to the LLM model. So then after defining those tools that are being defined for the LLM, we actually have what our tools do here. So here we have check availability. So as you can see, all of these tools are actually dummy, where, it returns available. For lookup appointments for patient, it returns this kind of dummy appointment. Lookup patient returns, this dummy patient. Create a patient creates this dummy patient. You understand all these tools are actually not doing anything, but that's because this is where you integrate with your actual system. So check availability. If you're working with Zenoti, you're going to go into Zenoti, you're going to find their API documentation, and you're going to find out how, based on their documentation, how do I check availability for my appointments based on their documentation. So you go into API reference, you'd find, again, availability. I've never worked with Zenoti, so I don't know how to do this. Retrieve available slots for a service booking. That is what it will be. Here, you're going to put in certain things like, probably the appointment type or the actual service, booking ID right there. So that is it. And so that is where you're going to define that thing in this function right here. And you're going to do the same for lookup appointments for patient, which is basically looking up which appointments a patient has based on their patient ID, or maybe it's their client ID. Obviously this is going to differ on what system you're using. You're going to do the same for lookup patient, create patient, book appointment, cancel appointment, reschedule appointment, take message, and transfer to human. So those are where basically your functions are actually being defined, and where your functions actually do a real world thing, which is like checking availability with your actual software, with your API keys, with your logic. And so that's what's happening in model config.py. Now, the last file you're going to need to look at is rag processing.py. This basically just is all to do with rag. So there's a function for initializing the RAG system. There's a function for shutting down the RAG system. There's a function for adding scenarios to Qdron. There's a function for actually, doing the RAG lookup, and that is it. So here is where I would personally add all of my scenarios. So what I would do is something like this. I would do define main, and my God, I can't spell when I'm recording. And then what I would do is I would await initiate RAG system. So like this, which is basically initiating the RAG system. Here, I would input my collection name. So I would just put MedSpar name here. I don't know why I can't type when I record. It's just hard to type and talk at the same time. And then I would define all my scenarios. So as you can see here, we have context response guidelines. Obviously, it's not going to be to do with the Tokyo weather. And then we would have user says, don't forget that, which is, again, defining what the user might say for that scenario to be triggered. So, in this example, they might say, what is the weather in Tokyo? And then we have not bot says, but we have assistant says. So that would be a scenario, and we would do, you know, hundreds of these depending on what scenarios we want to do or how many we have. Then we would add all of those scenarios to Qdrant using this function, and then we could just test if that worked by doing rag lookup. So that is what I would do to add scenarios into our Qdrant database. So that is it for all the code. Now I'm going to quickly show you how to actually go ahead and get all of the information, or actually let me just tell you all the information you need to know in order to deploy this online and get it actually running and working. So the first thing you're going to need is your daily API keys, which is simple. You're going to go into daily.com, or actually dashboard.daily.co, and you're going to go into developers right here, and your API key will be there. I'm not going to go there because it's going to save me some time blurring that. Your daily API URL is going to be that. You're going to grab your Twilio account SID and your Twilio auth token, which is, again, very simple. I've shown this in so many videos. You're going to log in the dashboard. You scroll down a little bit and it says Twilio SID and Twilio auth token, and you're going to copy and paste next to the equal sign. Then we need our service keys. So this obviously depends on what service you're using, but we were using Cartesia, Deepgram, and Cerebrus. So we're just going to grab our API keys and paste them in here. Then for Qdrant, what we're going to do is we're going to sign up to Qdrant, which is pretty simple. You're going to press get started. I'm going to log in. You're going to create a cluster. So if you see here, we have this Artilo AI cluster, which, as you can see, is on the free tier. And so what I did was I just created my free cluster, chose a name for it. So obviously I chose Artilo AI. You're going to choose a cluster provider. So, you know, AWS, Google Cloud, or Azure. You're going to choose a region, and you're going to create your cluster. There won't be much options you can do other than that with your free cluster. Then what you're going to do is you're going to go into details, and you're going to see this endpoint right here. You're going to copy that endpoint. You're going to paste that into the URL. That is what you want to put in the Qdrant_URL. And you're going to grab your API keys under the API keys section and paste that in there. Then for your RAG collection, name it whatever you want to name it. This doesn't matter too much. And then for the environment mode, keep it as local, because we're not going to be using Pipecat Cloud. We're going to be using fly.io for integrating. So once you have all your API keys, you are good to go. The only thing that you need to do is deploy this code to fly.io. So this is what we're going to be using to deploy our code to the cloud so that you can have it running, you know, obviously not locally. Now, to do this, I'm actually not going to show you on this video. With the resources from this video and the code, there is going to be a step-by-step guideline on how to deploy to fly.io. The reason why I'm not going to show you on this video is it takes a while, and I don't want this video to be an hour long. And so there's going to be, like I said, step-by-step with the exact terminal commands you're going to need, with everything perfectly written out for you so that it is very, very simple to do. And yeah, that is it for the video. I hope you found that useful. Obviously, all the logic is happening in Pipecat. If you want any help with integrating, deploying, whatever you have issues with for this MedSpa system, just join my school community where, you know, all the code anyway will be and the resources, and basically just ask for help there. You know, either myself or hopefully someone else in the community will help you out. And yeah, I hope you found this video useful. Thank you for watching, and I'll see you in the next one.